Hey guys, welcome to your third video in network security and cryptography. In the last video, we talked about the symmetric cipher model, and we discussed the Caesar cipher and the monoalphabetic cipher. In this video, we'll talk about some more symmetric substitution ciphers. And that includes the Playfair cipher, the Hill cipher, and I always get this word wrong, the Vigenère Cipher. I think that's how you say it. So let's get started. So one approach to improving security is to, of course, encrypt multiple letters. It treats diagrams, which is what's called a two-letter combination, in the plaintext as single elements and translates these elements into ciphertext diagrams. So the Playfair cipher uses a 5x5 matrix of letters based on a keyword that is shared. So for example, the keyword is monarchy in this example. And the letters that haven't been used by the keyword are just placed underneath, usually combining I and J, as we know we have only 25 spots when the alphabet has 26 characters. So the plaintext is encrypted 2 letters at a time, and we have 3 general rules when it comes to the Playfair cipher. So the first rule is if we have repeated letters, we need to insert a filler. So for example, rule 1, so we have the word balloon. Now balloon, as the Playfair cipher treats each input, I guess you could call it, as we need a 2-letter combination, so a diagram, right? And we have a repeated letter here, okay? So what we're going to do is we're just going to insert a filler. So balloon becomes BALXLOON. And there we go. That's what we would use to input into here. The second rule is, let's say we have a diagram fall into the column, the same column. So we'll use A and R. Okay, so A and R actually becomes RM. So A becomes R, right? And R becomes M. So it just wraps around. The third one is if they fall into the same column. So for the example, we use M and U. So M becomes C. So we'll go M, U. So M falls down and becomes C. And U wraps back up to the top and becomes M. And that's our 3 rules. So if your diagram doesn't meet any of these 3 rules, that's okay. We have an otherwise. So otherwise, if it doesn't meet any of these 3 rules, each letter is replaced by the one in its row in the column of the letter of the pair, if that makes sense. And by what that means is that, for example, HS, where it's H and S, so here and here. So HS becomes BP. HS equals BP. So H, right? We see here's S. We have a sort of square happening here, right? So S is in this column. So we move across and H becomes B. Just the same as S. As S. So H is in this column. So S moves over and becomes P. I'll do another example as well. So EA. Let's use EA. So EA would become IM, right? So we have a look at E, is over here. So E becomes I, so we go E and A. So E becomes I, and A becomes M. And that is the Playfair cipher. So now we move on to the Hill cipher. So the Hill cipher is quite easy if you're good at mods and multiplying matrices, but if you're struggling a little, that's okay. I did also. Just look up a tutorial on how to multiply matrices and you'll be fine. So first off, we need to assume something, and that is giving a number to each alphabetical character. So we can say A equals 0, B equals 1, all the way up to Z, where it'll equal 25. So we need a plain text to encrypt. So let's use the word puzzle. And we need a key. So this is just a 2x2 matrix. So 9, 5, 4, and 7. Hopefully you can read that. Okay, so now first off, what we need to do is we need to times we need to look at puzzle, and we need to give puzzle its numbers from what we assumed. So from what I see, this will be a 2x3 matrix. So we need to put that into a matrix. So it is 15. Whoops. So P is 15. U is 20. Z is both. Whoops. Z is both 25. And E would be 4. Okay. So now we need to times these two matrices together. And like I said, if you're uncertain, just look up a tutorial on how to times matrices and you'll be fine. So the resulting matrix from these two gives us 2, 1, 5, 2, 1, 5, 3, 2, 5, 300, 1, 1, 5, and 83. So now we've times our key with our plaintext. So now what we need to do, we need to do a little bit of math on this. So what we can do is we can perform what's called a mod. So a mod's just finding the remainder. So if you're unfamiliar with that, just look up a tutorial on how to do it. It's very, very simple to do. So I'm going to perform mod 26 on this matrix. So that matrix there becomes 7, 7, 13, 14, 11, and 5. So with this matrix here, this is our ciphertext. And what we can do is we can lay it out. So we get 7, 7, 13, 14, 11, and 5. And if we apply that to what we've assumed up here, what we get is we get H, H, and O, L, and F. And that is our ciphertext that we send to our friend. So now what we're going to do is we're going to go ahead and we're going to decrypt this with our key. And I'm going to show you how we can get back to the original plaintext. Okay, so to start the decryption process, we need a couple things. First off, with the ciphertext that we had before, which was HHNOLF, we need to put that back into its matrix form. So let's go ahead and do that. We have 7, 13, 14, 11, and 5. Now here's the magic. With our key, so our key is, scroll back up to it, 9, 5, 4, 7. So we need to invert this matrix. We need to invert the key. So when you invert this matrix, you get inverted equals 5, 15, 12, and 25. Now all we do is we go the inverted key, which is 5, 15, 12, and 25, times the ciphertext in matrix form, obviously. And we get 7, 7, 13, 14, 11, and 5. And when we times that out, we get some big numbers, well, not really, but so it's 2 by 3. So we get 119, 280, 233, 545, 115, and 290. So that is our inverted key times our ciphertext. Now, you probably guessed it, we perform a mod 26 calculation on this, which turns out to be 15, 20, 25, 25, 11, and 4. So I'll write that out. So you have 15, 20, 25, 25, 11, and 4. And that, my friends, if we put back into letters, we get our plain text, which is puzzle. So now we can talk about polyalphabetic ciphers. So these ciphers have the following features in common. So they're a set of related monoalphabetical substitution rules, and it's used as A determines which particular rule is chosen for a given transformation. So the simplest polyalphabetic substitution cipher is, I can't pronounce it, but it's the Vigenère Cipher. So Vigenère. So I'll run you through an encryption and a decryption process. It's quite easy. So first off, just like with the Playfair Cipher, we need to assume that A is equal to 0, B is equal to 1, and Z is equal to 25. So, let's encrypt meet me here, right, with our keyword. And our keyword for today, can be YouTube. So first off, what we need to do is we need to put the repeating key above meet me here. So first off, let's write meet me here out. So above that, we will put YouTube. So let's make sure you repeat the key. So after that, what we need to do is we need to convert YouTube and meet me here, just like how it is out here, from letters into numbers. So let's go ahead and do that. So we get 24, 14, 20, 19, 20, 1, 4, 24, 14, and 20. Sorry guys, I'm just trying to squeeze that all in there. So under that, we'll repeat meet me here. So I'll just do it in a different color. So it becomes 12, 4, 4, 19, 12, 4, 7, 4, 17, and 4. All right. So now that we have the letters converted into numbers, we're just going to do some simple, very, very simple addition. So we're just going to plus each column, you could say. So the first one, which is Y and M, will become 24 plus 12. So we get 36. I'm just going to go ahead and do it for all of them. We get 18, 24, 38, 32, 5, 11, 28, 31, and 24. Okay, so that's our key and our plain text plus together. Just draw a little, whoops. Just to sort of separate things a little bit. So now what we need to do with this line of numbers here is perform a mod 26 calculation. So we get 10, 18, 24, 12, 6, 5, 11, 2, 5, and 24. So if we convert back to letters, we get K, S, Y, M, I, F, L, C, F, Y. And that right there is our ciphertext. So now it's time to decrypt our ciphertext. So first off, just like with our encryption process, we need to assume A is equal to 0, B is equal to 1, Z is equal to 25. It's a funny looking Z. Okay. So we're going to place a repeating key underneath, then find the difference between two numbers. So all you're doing is you're subtracting the ciphertext from the key. So let's get started. So we'll write out the ciphertext first, which was 10, 18, 24, 12, 6, 5, 11, 2, 5, and 24. Now we'll put the key, which was YouTube, underneath. So we get 24, 14, 20, 19, 20, 1, 4, 24, 14, and 20. So we're going to do a little bit of subtracting here. So you have 10 and you minus 24. And we get negative 14. So negative 14, you get 4, negative 7, negative 14, 4, 7, negative 22, negative 9, and 4. It's a horrible line, but that's okay. Okay, cool. So now, that's right. We need to perform a mod 26 calculation. So these get a bit funny when it comes to negative numbers. It's quite easy when you work it out. Just look up a tutorial on how to do it, or I can run it through you in another video. Let me know if you guys would like to see that. There's a few tricks how you can do this. So when we perform a mod 26 on this, we get 12, 4, 4, 19, 12, 4, 7, 4, 17, and 4. So now when we convert that straight back, we get meet me here. And that, my friends, is the Vigenère Cipher. So thanks for watching, guys. That wraps up our third video in network security and cryptography. Make sure to stick around next. I'll have a few more videos coming out very, very soon. Thanks.